Hello, world. I'm Chris Perillo on behalf of the New Stack. Welcome in. Thank you for joining us for this webinar. Today, I'm joined by Andrew Hillier, CTO and co-founder of Densify, and we're covering automating Kubernetes resource management to reduce developer burden. Thank you for spending some time with us to kind of unpack this, because this is not going away anytime soon. And to be able to talk about how to reduce developer burden, I think it's critical. I mean, it's not necessarily something that all companies consider, right? You've got developers, but how much burden are you throwing on them? How can you reduce it?
Yeah, absolutely. I mean, I think developers should be focusing on time to market of new application features, new services. That's what makes a company competitive, and having them spend a lot of time trying to figure out, what their utilization of their container was for the last few months so they can correct some numbers isn't really the best use of their time. And in fact, it's probably not the best use of anybody's time. It should be done by software in our point of view. So, they're often the ones that can affect the change and automate things, but they really should be focused on innovating. So that's I think that's a great theme for today is how do you get that off their plate so they don't have to think about it and they can think about what they should be focused on.
Well, why is it so hard to make Kubernetes run efficiently?
Well, I mean, there's a lot of moving parts. I can get into some detail. I can pull up some analysis for you, Chris. But I think in a nutshell, and maybe we can just flip to some slides and I'll kind of give a bit of an overview. I think the fundamental thing we see is that from a spend perspective, obviously cloud is a big spend. Obviously on-prem is a big spend as well. There's all kinds of strategies out there, and there's lots of solutions to kind of fix the clouds, or at least to understand the cloud spend and possibly to lower it. But when you get Kubernetes going on inside here, there's a lot of moving parts inside that. And you can have things that are too small, things that are too big, things that don't have values, and it all makes this big mess inside the environment where you could be running on more infrastructure than you need. You could be running on less, and you want to fix this because there's a lot of risk and a lot of waste. But the problem is there's thousands of these things. It's almost like having to give a resource spec to every process running on your PC. And now you might say, is it process or process? Because I think that.
Hang on. I'm hearing Canada. I'm hearing Canadian. Am I right?
You are here in Canada. Yes, you are correct. So from a process or process, it's difficult to fix this because, we have customers with hundreds of thousands of containers, and you're going to go back and change hundreds of thousands of containers settings. I can pull up some examples, but it's really a challenge to figure out. And to kind of make it worse, exacerbate that, I think there's only one pronunciation of that word. You've got different teams involved in the mix. And there's always been different teams involved, like capacity management, if you go way back and things like that. But you've got teams that want to make sure there's enough capacity to run the apps. Usually everybody wants to make sure there's enough capacity. You have teams that want to make sure there's not too much and wasting money. And then you have platform owners that are somewhere in between there. And they might care about both those things, or sometimes they don't care about either, depending on the organization. And there's a whole lot of complexity inside Kubernetes, which makes it hard to figure out. So, how much you run on the actual servers or cloud instances or bare metal that you run on is what causes the cost. But how much of that you need is based on what the developers and app teams ask for. So, the concept of requests and limits. You need to request CPU and memory and limit yourself. And if you get that wrong, then Kubernetes is forced to run more hardware than it needs the job. And again, this is where it gets interesting, because so do these app teams spend forever worrying about this to try and save money, or do they worry about their application functionality? And the way we like to think of it is that you need to look at all of this at once and analyze all of it at once and figure out what do the containers actually need. And this is a kind of a pretty picture that I'll show you in some detail what this is actually saying, but we need to understand, are the containers too big or too small, or do they not even have values? And understand what the optimization opportunity is, and then how that translates to the infrastructure you're running on to make sure you have the right amount of infrastructure, which is where you save the money. So we're seeing a lot of organizations find there's a big spend problem with Kubernetes. There's also a big risk problem with Kubernetes, but figuring this out and then automating it, up and down the stack is how you fix it. And you don't fix it by asking developers to spend a year looking at spreadsheets and editing the repository files for 10,000 containers. That's probably not the best approach to this.
Well, how bad is the problem?
I'll show you some of these pictures live.
I love a good demo. I'm a visual learner. So as soon as you throw up charts and graphs, I'm like, okay, I'm in.
Yeah, and visual is important here because there are a lot of moving parts in this world. And you can just see from this screen that I have up that there's a lot going on here, and I'll simplify it in a second. But basically, we're looking at an analysis of a Kubernetes environment. And I'm not going to go through this whole screen because this is kind of summarizing the dollars and the savings and all that kind of stuff. But what I'm going to quickly do is go over to what we call the histograms. I'm going to go to a visual first because you like visuals. I will mention that you see down the left here, these are all Kubernetes clusters. So you can point this at any number of things. You may have customers running hundreds of thousands of containers across dozens of clusters, and I can look at individual clusters and see, what they look like. But I'm just going to look at kind of everything in this environment. It's not a big environment; it's about just under 3,000 containers, so it's small as far as container environments go. But you start to get a picture of what goes wrong in these environments. So the way you read this is for containers, you need to give them requests and limits, and you need to give them that for CPU and memory. So the top left curve here are the CPU requests. And then the top right are the memory requests, and then the CPU limits and memory limits. And this is basically an analysis of, is the request correct? So the green bar means, yeah, you have about 500 or 600 containers that you're asking for the right amount of CPU. You ask for a CPU and you're using about a CPU. There you can hear a little Canadian about there. The red means you're not asking for enough. So way down at this 20%, it might mean you only ask for one CPU, but you're using 5 CPUs. Or more, or 10 CPUs, or 20 CPUs. So that starts to cause a problem for Kubernetes because Kubernetes places containers on nodes based on what you ask for, not what they do, right? So if I don't ask for enough, then if I have enough of that red, I will start to overstack all my nodes and things start to perform poorly. Gray means you didn't even ask for anything, which is a different kind of problem. You should really ask for something. And then yellow is too big. And the further you go, the worse it is. Right up to the 500% bar means you're 5 times too big or bigger than you should be. So you ask for 10 CPUs and you're only using 2 or only using 1. And so this starts to paint a picture of how bad the problem is because it's like an MRI for your container environment. And just looking at CPU, you can see, wow, everybody's asking for way too much CPU. And that forces Kubernetes to run a lot of nodes. So there's enough CPU to schedule the containers. Red is risk, yellow is waste. And you asked how big the problem is. Every environment we analyze looks like this, where there's this big yellow bar, because the developers or the app teams, they probably don't know what to set it to.
Yeah.
Or if they do know, they're going to set it to a high watermark to be safe. But overall, you end up asking for way too much and wasting a lot of resources.
Yeah, I've never seen it visualized like this before. I can't imagine this not being helpful.
It's tricky because people think, wow, this is awful. We look awful, but I have to confirm or assure them that everybody looks this way. You're not doing anything any worse than anybody else. It's just.
But you're able to see it, right? It's not just a number on a spreadsheet, right? It's an actual graph, a dynamic, chart that effectively shows where you're over, under, etc. At least to be able to dictate like which direction you need to go and where.
Yep, for sure. And you can click on it and then you can actually fix it, which I'll show you. What you really want to do is fix it in a kind of collaborative way. But before I go there, let me go down. You see on the left here, I'm in the containers. I can also look at the nodes they're running on and even the cloud instances that those nodes are based on. And if I go down to the nodes for a second, I'll just show you what that yellow bar does. I'm going to go to an K8s cluster here, and I'm looking at, there's a bunch of node pools in this cluster, and I'm just going to go straight down to some of the nodes. So here's a node. This is an Azure, what is this? A D4DSV5. It's got 4 CPUs and 16 gig of memory. And you see this CPU down here. This is what happens when you have that big yellow bar. So I'll pop this open. This is the CPU utilization of that node over day on day back through history. And I can even go down and say hour to hour. I can look at the 5-minute data if I want. But you see this thing only ever runs around 4 or 5% utilization. This couple of days here, it did peak up as high as about 12% utilization. So these are quartiles, so the sustained and peak activity. But the requests are 90% of that node. So everybody's asking for a lot of CPUs and then not using them. And so you end up looking like this, where you've given out all the CPU capacity to all the containers and they're just not using it. And again, everybody we analyze looks like this, and that's wasting a lot of money because if you see here, if I bring that orange line down just to say half of the capacity of the node, memory working set is already below half. So memory's not a problem. This is all buffering, this middle one here. If I bring that down there, I can run on half as many nodes. If I reduce the CPU requests, if I'm just not so crazy big on the CPU requests. So that yellow bar I showed a minute ago, if you can get that down, this orange line comes down and you save half. In this case, you would run on half as many nodes. So it's a pretty compelling value, but we have to be careful fixing it because it can be tricky to actually do. And you really want to automate it so it's done without humans spending years doing it.
My God. It's just, if a company has these issues, What can they do? And as you said, this is kind of like, I'm not going to say an amalgamation, but a lot of companies have these same issues. So what can they do about it once the problem is very clear, like right there, right in their face?
Let me drill down this a bit more. These bars, I can click almost anywhere on here, and I won't go through all the details of this. We can probably provide links to other presentations and videos that go deep into how it all works. But I'm going to click on that big yellow bar, and I get the top offenders, the worst containers from an oversizing perspective, the ones that are just too big. And so let's look at this first row, and you can see that the data down here. This one was given 4 CPUs, 4,000 millicores is the way you request in Kubernetes. And the analysis is saying, you really only need about 1.5 CPUs from a request perspective. And I can see that in this curve down here. So if I pop this open, we call this the ML model. This is the machine learning model for that container. So we go back through all the history and figure out what it does by hour, what the operational pattern is of this thing. And you can see it typically goes almost up to 1 CPU. So it doesn't quite go to idle between midnight and 1 a.m. It doesn't go idle, but it goes close. It spends half its time in that thick blue zone, and it peaks as high as the thin zone here. So early morning hours, it doesn't even hit a CPU. It goes a bit above a CPU at peak, but using about half a CPU sustained. And then early afternoon, it does go as high as almost 3 CPUs. So when you see that pattern for CPU usage, you don't need to request the peak, because that means you've kind of locked all that capacity for yourself, and you're clearly not using it all day long. And the analytics, it's all policy driven. In this case, it's saying you've requested 4 CPUs, which is really wasteful. You could be requesting down here around 1.5, or even lower possibly. Again, it's all tunable. If you do that, that frees up all those CPUs to be used for something else, or to not be deployed at all. And if I go out of this curve, you'll see there's 30 of these things running, 30 replicas on average. So that's about 70 CPUs of waste. There's just 70 CPUs that are being requested out, and they're sitting there on the floor, quote unquote, not being used. And that actually wastes quite a bit of money pretty quickly when you have this kind of thing going on. Again, that's where if I bring these numbers down, if I set them to what this recommendation says, then I free up 70 CPUs of capacity. And Chris, we've seen like one container wasting about $250,000 a year of CPUs, just because somebody made it too big and they didn't go back and revisit it, or they didn't know what it should be, or that's made sense at the time, or whatever that is. But in the long run, you really want to fix this and get the request down closer to what the utilization actually is. And you can see that on these curves down here.
When you talk about fixing, how easy is it to fix from this, let's say from this experience, from this interface?
There is an automation controller. So again, this number is key. This column here is what you want to make it. Like I said, I'm not going to go and start doing pull requests and edit, 10,000 containers manually. So if I go over to the side here, you'll see there's an automation controller. It's deployed. There's 2 components that we deploy in a cluster. There's a forwarder to get the data, it's kind of read-only thing, and then this automation controller, which can change things. And it's pretty smart. It can do what's called mutation, and it can mutate things on the fly and say, okay, when you're starting a new container, I'm going to make you the right value as you start. So instead of having to go back and revisit all the source files, you can just override it on the fly. And there's now what's called in-place resizing, which makes it even easier. I can just resize the container as it's running. So this automation component, you run one in each cluster, and it just automatically takes care. You can see on the right-hand side here, it's just humming away, fixing it based on policy. And you have really fine control over how you want to fix it. I'll show what the net impact of that is. So with that automation controller running, if I go back to my home page here, on the far right, you see there's an automation section with the automation happening. And these are all the automation events where containers have been resized. And I'm going to go down to one here that I know is interesting looking. I can click it open, and here's a case. So this is an automation event. So this is basically happening automatically when that container got started, or the controller can also restart a container to resize it. Its CPU request was increased. The memory request was decreased quite a bit, and the memory limit was decreased. And I can see that graphically down here. At this point in time, the automation controller automatically increased the CPU and decreased the memory for this thing. And it will just then maintain that after the fact. So once you enable automation, it will just keep doing this automatically, but it gives you a full audit trail of what it's doing, so you can make sure you're happy with the results and verify that it's still working properly. That one on the right, for example, that memory downsize might save quite a bit of money because it's a pretty big downsize. This container is not using that nearly as much memory as was requested. That orange line was way higher than the blue line, is the way you see it.
This is just me, right? But like, if you're doing anything with Kubernetes, this seems like a critical tool to have, because it could save you resources, time, money, pain, burden. I mean, that's pretty slick.
Burden is a great word. It's interesting you said that, because the burden is a big part, because you want this to be right. I mean, you don't want to run with this wrong. Like, there's all kinds of issues that creates. And I'll talk about risk in a second, because I've just been talking about saving money, which is kind of what the right-hand one here is doing. But the left-hand one is actually de-risking this environment, because I can be wrong in both directions. And so if I don't ask for enough capacity, things go wrong, sometimes very spectacularly wrong. In our view, and I think you seem to agree that this is a pretty important thing to get right, as long as the burden of getting it right isn't too high. So if I'm adding the burden to everybody, that's one thing. But if I make it easy, if I just say this is analyzing it, you can say, okay, I've seen what this does. I trust this now, because that's exactly what the utilization was, and it's just aligning it. Lovely. I trust the machine. Just do it for me. When you get to that point, then there's huge benefits, because it saves cost, it saves risk, and it decreases the burden. But what we found is it's very important to be very transparent in what's happening and show all the data so that you can trust it to let it take action.
Interesting. And like I said, a lot of the stuff when we talk containers, it's all nebulous to me. Again, I'm a visual guy. I'm like, this makes sense. This totally makes sense to me. And I can't imagine developers saying anything but that.
Yeah, I think it makes sense at multiple levels. I did a webinar one time where I did an analogy where if this was my laptop, and let's just say, I have PowerPoint up right now. I have this Chrome running with this demo in it. And if I had to go through and give millicores and megabytes to each of my processes, what would I give them? I did the exercise saying, yeah, my PowerPoint, it gets pretty busy when I'm doing animation. Let's give it 2 CPUs, and let's give this thing 3 CPUs or whatever it is. It added up to 8 laptops, right? If I have to individually size everything based intuitively on what I should give it, it adds up to way more than I have. But I know everything fits on my laptop. It's not all busy at the same time.
Right.
Things share resources. So that's the same thing that happens here, where you give everything individual values, and then in aggregate, you end up with 8 times the nodes that you should have to run these workloads.
Do companies, in terms of the automation stuff, do they adjust those recommendations manually, or do you find that they're using the automation processes that you have in place?
So they're increasingly using the automation processes that are in place. It's a great question, because I think you need to trust the automation component. And we just worked on a major rev of ours. It makes it very smart, because if you think about it, if you do it automatically, there are things that can go wrong. And it's hard for me to show this graphically, so I'll just describe it. But if I'm making a limit bigger, which seems to make sense, because if I'm hitting my limit, I'll talk about that in a second, and getting out of memory kills, I might want to make it bigger, but I might then exhaust my quota. So you need to make sure if I make something bigger, I don't exhaust quota. I don't make it bigger than the nodes I'm running on. There's the HPA. There's a component called horizontal pod autoscaler that turns on and off pods based on load. You can mess it up spectacularly if you do the wrong sizing for something that it's scaling on. Like if it's scaling on CPU and you resize CPU, it can scale out of control. And I did a whole webcast on this as well. We can probably provide the link on all the stuff that could go wrong if you don't do it properly. So I think, yes, everybody wants to automate. I think you have to make sure the automation is powerful enough to do it correctly and not do harm. And that's exactly where we are. We've gotten to the point where our automation controller is so powerful that it just checks all these things to make sure it's not going to do something else, an unintended consequence. We're seeing much bigger uptick in automation, because I think, of course, you don't want to automate in a way that messes things up. But that's the holy grail, is to get to full automation on these things, where I just don't think about it. I let it do its thing.
When you resize the containers, what happens?
If I bring this yellow down, I think I showed you already at the node level, the orange line will come down. I have a slide that I could get into more detail, but I won't bother flipping over to it. But for example, if you're running on scale groups, what happens is the scale groups are scale sets in Azure. As you fix this yellow bar, it will automatically start running a different number of nodes. If you bring that yellow bar down enough, then what will happen is we'll say, hey, you should move to a memory optimized node type, because you're not using all that CPU anymore. And so we see that quite a lot, and our product will recommend that. That's down under this cloud icon, where it says, okay, you've optimized your CPU enough now that I'm going to run you on an R instead of an M in Amazon, or an E instead of a D in Azure. So it will automatically adjust the node types to match the workload composition as you go. So basically, if you start fixing these things and automating these things, it will automatically adjust the infrastructure to realize that cost savings. If you're using Carpenter, then Carpenter will start auto consolidating, because Carpenter will also run too many nodes if these yellow bars are too big. So as you bring it down, Carpenter will start running different node types or fewer nodes. And so it just started to happen automatically, and the whole thing just becomes much more efficient because you're just asking for what you're using, not 10 times as much as what you're using, and then all the infrastructure becomes more efficient.
Again, from someone who doesn't work with Kubernetes on, I know the word, like I know enough to gather context of what this component does, what this component does. It sounds pretty straightforward to turn on automation and go, but what's the catch? Like, it just seems almost deceptively simple. The easy button, if you will, like press the easy button, it auto adjusts, you're saving money. Like, am I missing something?
There's a couple of things I'll talk about. So one is that, again, I mentioned there's those 3 groups involved, right? So if I'm analyzing this and I find a container that's got, let me sidetrack for a second, Chris, and then I'll answer your question. So let's find a cool example of a container that's got a problem. So I've talked about the ones that are too big and I want to make them smaller. They can also be too small and you need to make them bigger. So memory is usually a bit of a mess of too big and too small, like the red and the yellow. But if your memory limit is too low and you hit your limit, you'll get killed. So it's not just cost savings. I can actually go down here and say, what's going on here? And I have containers. I'm going to go to the second one because I like this DynamoDB example where it's living at its limit. Its utilization is hitting, the purple lines are the limits. It's hitting its limit and restarting like a lot. It looks like it restarted 162 times yesterday. So this is the flip side of it. If I make things too small, then I have all kinds of, I have throttling, I have out of memory kills. If it's too big, I'm wasting a lot of money. And the reason I chose this one is because I can go down to the actual homepage for this object. You see now I click down, I've navigated down into the cluster in the namespace of this DynamoDB, and it has a homepage that's telling me everything it's doing as far as the metrics and all these things. I can view the metrics, I can view the policies, and this is deep linkable. So if I click this little link here, and this is very important, I can send this to you, Chris, if you own this thing, because I might not own it, I might be the one analyzing it, but we have a lot of different teams here. I can say, hey, owner of DynamoDB, did you know it's hitting its limit and dying all the time? Well, I can just take this link, and I can even put it in the chat right now in this webcast, and you'll be able to click into it and hit this object and see this. And I can go and say, okay, show me the 5-minute data for memory utilization, and show me that alongside the CPU utilization, the number of kills, whatever that is. So we've done a lot of work on to make sure that it's transparent and the evidence is made available to people, because somebody who owns this thing needs to agree to fix this. Now, in this case, it's got a no-brainer. It's dying. So you should make it, we're going to make it bigger, okay? But if it's something that's too big and we're going to make it smaller, all of these things are deep linkable. It's part of a bigger collaboration kind of use case where we designed the product so that it basically multiple groups can collaborate with each other to achieve the end goals, because no one group can do it. You might have a FinOps team that cares about saving money, but they're not able to change anything technically about the workloads. Then you have an app owner that owns this thing and is the one that gave it these requests and limits, who are the ones that need to take the action, and they may be the beneficiary, maybe not. So in here, there's a whole bunch of collaboration capabilities, these deep links. I'll also show you another one that's interesting. If I go back to this, what we call the analysis details table, this is like Excel. I can reprogram it, I can search, I can filter, I can pivot. I can say, take the namespace and pivot on it and start giving different answers, and I can save them under different names. So Chris, if you owned an application and you were responsible for its cost, I can make a view in here that filters down on your app and highlights the cost, and I can give you a link to this report right in the product. So it's like Excel built into the product that you can program and save and use that to collaborate. So that we see that like FinOps and SREs teams using this to, I can even reprogram this tree view. I can make different views in here of how I want to view things. So it's very programmable to foster collaboration where you've got a job, I've got a job, and I can communicate with you very precisely through this mechanism so we all achieve our goals.
Since we are talking about technology, we cannot avoid the topic of AI. I think it's now by law, I have to say AI in everything that I talk about anymore. We got to talk about AI. Does that have the same issues?
Let's break that into two things. So yeah, you very astutely saw some AI up here. I'll get to that in a minute because that's very much on theme for this whole empowering developers, empowering anybody, almost democratizing access to what I'm showing. But before I go there, let's talk about optimizing AI. So AI is an interesting topic for us because we're doing a ton of work on it in two distinct areas. One is an AI experience and interface to everything I'm doing now, but the other one is optimizing AI workloads. So you see at the top right here, I've got 6 containers running on GPUs. And so if I click on that, you'll see now I'm in a GPU inventory, and a lot of these are AI workloads. Some of these are just test workloads, but there's a TensorFlow, there's a couple of TensorFlow, a learning and an inference model running on GPUs. So we're starting to see this emerge as a big challenge where maybe you're not using your GPUs so well. So picture if you have, we have customers that have hundreds of GPUs, and if they're not used well, I use the phrase yield. If you're not getting a good yield on your GPU, you're wasting a ton of money because these things are so expensive. So this top one you see is a container that's running on a Tesla T4 GPU, and I can see how it's using that GPU. I can see the GPU power consumption. And so this one's not bad. It's kind of fluctuating, again, based on the machine learning model. Over 24 hours, it's going as low as about a third of the GPU and as high as about 2/3 of the GPU until midday when it's actually peaking at the whole GPU. So this isn't bad. It's probably okay because it's on average using a decent amount of that GPU. And so that one's pretty good. But if I go down the list here, let's find, even the second one, you see this one's peaking at about a seventh of a GPU. That's 0.14 is the very top of the curve here. So this one is wasting a ton of money because I'm giving it a GPU, and GPUs are expensive. And on average, it's probably not even using a tenth of the GPU, but even at peak, it's barely using a fraction of it. There's things we can do to optimize this. And we have quite a few customers that have pretty big GPU farms, and we're finding it's ever expanding, where maybe I don't give it this GPU, maybe I give it a different GPU, or there's what's called MIGs or slicing. So maybe I can give it a fraction of a GPU. A lot of the newer GPUs you can chop up into smaller GPUs. So this will generate a full MIG plan for you to say, okay, that one only needs a quarter of a GPU, or even this one probably an eighth of a GPU, and it will read out all of the requirements of all the containers and then give you a plan to say, basically configure my GPUs. And usually it looks like from the numbers we see, you could probably get by on about half as many GPUs as you're on right now, which is just an astronomical savings number, given how expensive they are. So AI workloads running, especially running inference on Kubernetes, we're seeing a lot of that. If you've got it in your Kubernetes environment, any GPUs running in there, this will analyze it and tell you, okay, you don't need that whole GPU, or you should be using this other smaller GPU or something different. And there's some new stuff I'm not going to show it today that we're bringing out at KubeCon. If you're there, we can connect. Some brand new visuals and features around GPU optimization that are really cool. So it'll just basically analyze your AI workloads and say, yep, here's how you should configure the infrastructure to get good response time, but also not waste a ton of money. Because that's exactly what happens with GPUs is you're in a hurry to get the app running. Again, back to the app teams, you want to get the AI working and get it out there. And in the process, you basically create a lot of inefficiency in the infrastructure spend because GPUs are just so expensive. So one side of AI is actually optimizing the AI. I can bring up the homepage for this thing and I get a nice GPU homepage telling me what it is, and it starts to give me the configuration recommendations. I can keep drilling down on it. So if you're running big, expensive AI workloads, this will typically save quite a bit of money.
So is that what's next, or what is next?
From an AI front, this is what's next in terms of, as we see a proliferation of especially inference out there, where people are taking off-the-shelf models but running them on Kubernetes. This is creating a lot of spend that we can fix. But the thing I'm probably equally excited about is this other tab up here, this cloud tab, which let's take a little look at this. So I'm going to go over into here, and now I'm in an LLM, and it doesn't have to be cloud, but that's what I'm using on my system here. And it's asking me how I am, and I think that's rhetorical. I'm not sure it really cares how I'm doing. But what we've done is we've made an MCP server. And many on the call may have heard of MCP, Model Context Protocol. I know you're probably familiar with your work in AI.
Well, I'm familiar with Tron, the MCP being the master control program, but I understand Model Context Protocol.
Yeah, it's funny. That's true. So they reuse the acronym, but true. MCP in this case. So let me just stand back and kind of describe a good way to think about this. It's like I've been using the user interface and it has access to a lot of information in those configurable tables. And underlying it is a very powerful data dictionary of all the analytics results, all the data, all that stuff. We've made that available through an API to the LLM, and that's through the MCP protocol. So you see here, I'm plugged into a sandbox, which is the UI I was demoing was in what we call a sandbox environment. And if I click here, you'll see now the AI has access to all these APIs, so we can start asking the very same questions, just not in the UI. So it's almost like picture you have a student, a very smart student that's sitting now in a chair at the UI that knows where everything is in any screen in the UI. And the student has read the internet, so they're pretty smart, and they can answer any questions. So I can start asking this thing questions. This thing could answer any question. It could give me life advice, whatever it is. But I'm going to tell it, okay, LLM, when I ask you a question, only answer from the Kubex APIs. Don't go off philosophizing about things, and give me little tables of answers. Just give me direct answers when I ask you. And then I'm going to go and start asking it questions. And I'm just going to start with some simple questions here. So, what are my top 5 container cost savings opportunities? And so this thing is now smart enough. I'll start simple. It knows how to call these APIs. It knows how to interpret all the columns of data. It knows how to refine its requests. It can even think it can try something and then try something else and figure it out. But what it's going to do is it's going to give me back kind of what I clicked on in the product there. This was in one of the screens I showed, but it's just going to answer it for me. So picture a world, Chris, where you don't have to learn the product. You don't know what our product does. You don't know anything about our product. I'm logging into this. I'm saying, hey, what are my opportunities? Well, here they are. After a lot of all the intelligence I went through, the deep links are here. So if I click there, it'll take me right into that object in the product. So this is the beauty of this, is that we've got the visual language. We've got a way to present to you everything you need to know about those containers and what to do with them. But I can start off with a simple question, and then it'll take me there. It's almost like the way Google, you can ask it a simple question, and then it'll take you to a web page or something like that. But I don't have to read all the web pages. I just ask it a question. So we think this is going to have a profound impact on the use of this type of technology, because I don't need to learn anything. I don't have to know what Kubex is. Let me ask it a different question. One that I didn't show in the demo. Do I have any containers with CPU throttling? It just knows where that is. I don't need to go clicking around the UI to find it. And you can see where this goes, because this starts to go towards agentic. I can say, well, can you tell me if there's any new CPU throttling? Yeah. Can you tell me if that automation worked or didn't work? Can you enable automation for me? All these things. There we go. I didn't have any CPU throttling the last day. Chris, you can start to see kind of the idea here where tell me what the biggest problem is and open a Jira ticket. Or you can start to combine multiple MCP servers together, which is exactly where we're going. And eventually, we think this will just be the next generation interface. Even things like back to our app teams, it can do things like, all right, I'm starting another thing. Well, how big should I make it? This is one of the biggest questions you might get from an app team. I've got a bunch of these things already running. How big should I make my next one? And it can answer that kind of question in a very simple and direct way. Back to the theme of saving developers time, like, there you go. I don't have to think about it at all. Depending on, he made little profiles for me. If it's high performance or not, this is what you should set the values to for the next one you start.
You're wearing a Kubex t-shirt. Am I correct?
Yeah, I am. Yeah, I am indeed. So
the point is taken. I think that integrating that way makes a lot of sense, because that's where developers are anyway. They're in their favorite tool set, and learning another tool can be a burden. So abstracting the value of what you do and making it familiar in context to a tool set that they're already running, I think that it's kind of icing on the cake, but it totally makes sense with the way that the world is going.
Yeah, for sure. And what we're finding, there's 2 threads here. One is kind of an enterprise, I'll call it co-pilot strategy, where you've got approved LLMs, and then you have centralized access, and this becomes an MCP interface. It's almost like a data lake, another interface that you can ask questions, and you can connect to this, you can connect to Atlassian or Wiz or other things. And we're starting to design really composite workflows around that can start asking questions of multiple things in the AI. So there's one where you're using Claude or OpenAI, whatever it is you want to use, interfacing with this MCP layer. The other one is we are actually building it into the UI as a prompt in the UI. And that's really cool, because it can do all of this stuff, plus it can navigate the UI and eventually recompose the UI. We call it the lovable for resource optimization, where I'm in there typing in UI, and it's actually reforming the right-hand side of the screen with what I'm answering. And we have the visual language to do that. It just pieces together and say, well, you asked this, here's your latest automation event, and here's what it did, and your throttling went down, and it just answers on the fly. And we really think that's exciting. And that's what we're showcasing at KubeCon. And again, I really think that's a big step forward. So the combined depth of the analytics and the ML, all the stuff we're doing, plus the AI, connective tissue to let you interact with it, we think that the holy grail for this industry.
Yeah, it totally makes sense. Andrew, I appreciate your time, your expertise, the fact that y'all are doing this, because like I said, you helped me better understand, and more importantly, know that there's a solution to problems out there.
Great. It was a great chatting with you, Chris. I'm glad I could shed a bit of light on this area.
Yeah, for sure. Andrew, again, thank you. Thank you, Densify. I appreciate the time and the expertise, and see you soon.
Yeah. Thanks, Chris. And thanks everyone for joining.